Hi everyone, today we'll discuss one more problem, one more property, division by t of the Laplace transformation. What the theorem says, if Laplace transformation of f of t equal to f of s, then Laplace transformation of f of t by t, that means division by t equal to s to infinity Laplace transformation of f of t. This conditional clause is there, f of t by t exists and the integral also exists. So let us go for the proof. What we have? We have Laplace transformation of f of t equal to f of s, which is equal to 0 to infinity e to the power of minus st f of t dt. Okay. So what we have? We have f of s equal to 0 to infinity e to the power of minus st f of t dt. Now what we are doing, integrating with respect to s both the side. Integrating with respect to s both the side. And the s running from integration from s to infinity. S to infinity. That's it. Next, s to infinity f of s ds as it is. Now you see this is for dt and this is for ds. So what I am doing is I am interchanging the integrals. That means 0 to infinity, yes, 0 to infinity, I am keeping as it is. Then this is s to infinity, I am interchanging. So it will be s to infinity e to the power of minus s ds will be. And what is f of t dt? I am writing here f of t and dt. Now what we are doing here, this part, please see this part only. We are focused on this part. This is as it is. The green one as it is I am writing. 0 to infinity f of t as it is. Dt also as it is. The blue part, if you integrate, this will be e to the power of minus st. Yes, with respect to s we are doing. So, constant is t. You see e to the power of ax dx. If we are integrating, it will be e to the power of ax by a, not x, because you are differentiating with respect to x. Okay, that's it. So now this is s to infinity. So 0 to infinity, you see f of t as it is, minus t, denominator dt, upper limit, if you substitute upper limit, e to the power of minus infinity is 0, minus e to the power of minus st. So minus minus getting cancelled, it is 0 to infinity e to the power of minus st f of t divided by t dt. So always what we have, this 0 to, let me write down this. This is f of t will be there in the integration for the Laplace. Now it is f of t by t. So e to the power of minus st f of t by t is nothing but Laplace transformation of f of t by t. It is nothing but Laplace transformation of f of t by t. And this is s to infinity f of s ds. So this thing similarly we can prove. We can prove this. We can extend it. So Laplace Laplace transformation of f of t by t to the power of n. Suppose, for example, it is like this. It can be going like this: s to infinity, s to infinity, s to infinity, so on, s to infinity, f of s ds. How many s? N times. N. How many times? N times. N times means s to the power of n. This can be extended. Very simple case, the property. Sometime it may ask they may ask the proof in the exam. The proof and one problem. So proof is very easy, just one small thing. Given, write down the Laplace transformation definition, then integration s to infinity ds, multiplying both the side by integral, definite integral s to infinity ds. Integrating both the sides, then integrand can be changed. You see ds with ds, you see you are changing just s to infinity ds, same. F of t, because it is a function variable. Here t is the variable. So we are not interested here. It is outside. This we are integrating e to the power of n minus st by t, because we are integrating with respect to s. So minus t. Upper limit is 0, minus lower limit is s. So this is minus minus getting cancelled, f of t by t. Laplace transformation of f of t by t equal to s to infinity f of s ds. That's it. Very simple. Thanks for watching. Please do subscribe my channel and share with your friends.